Hi everyone, very good morning and good evening. Let's start the session. Just a minute. Let me share my screen. Okay, guys. So in the last session, what we have discussed, so we discussed about how to work with a resource monitoring concept, how to control the billing in Snowflake, right? So now in this particular session, we are going to discuss about partitioning. Generally, so in our any traditional databases, so have to create partitions, right? So any databases when you are working, so if you wanted to, for example, increase the performance, so we need to work with partitioning concept, right? So now the here, so instead of like a partition, right, so here also, so the partition will be there, but instead of creating manually, right, automatically Snowflake is going to take care, automatically it is going to take care of creating a partitions. So when it is coming to, so this one, if you observe, so any database here, so when you are working with the sample, you may observe some of the tables. So if you see this one, this is huge volume of the table, right? So when you are running this particular query, I have given in a where condition, I have given L ship date, right? Where condition only, why I have taken this column, you will see that. When we are running this query, this volume is, if you observe, 160 GB data, right? And so generally, if you wanted to run any data from this, if you wanted to fetch any data from this particular table, so it is going to take like 15 to 20 minutes, depend on the performance, right? But here, if you observe, when we are fetching the data from this table, these many billion records, so how much time it is going to take? So when we are running this, so previously it has taken 5.07 seconds. Now let's observe how much time it is going to take. See this one, it is going to take 6.97 seconds, right? 6.97, 6.97 seconds it has taken. So how come? So it is very fast. So if you observe, go to open history, click on the query ID, we can able to see profile. We can able to see profile. When you observe the profile view, here you can able to see partitions scanned, and partitions total. Total number of partitions 10,336, and partition scanned is 5, means 5 partitions scanned in total 10,336 partitions. We didn't created any partitions here. Automatically it has been created. If you observe our normal tables also, whatever the tables we have created here, if you go to the class database and if you connect it to this, and any table if you take, for example, employee table, it's a very small table, and then if you check the data, so let's see, select star from employee, or other table I will take. This table is having data. Okay. Now observe this. This table, it has so only 10 rows, 326 milliseconds it has taken to display the data. If you go to the query ID, here also see this one, partitions, it's very small table. Partitions, it is telling that one partition, and partitions scanned, again it is only one partitions it is scanned. Only one partition to one partition it is available, only that partition it is scanned. It's very less volume of the data, but we didn't created these partitions, right? When you created a table, so how come this partition is created? What Snowflake will do is, so when the data is storing in the tables, automatically it is going to create a partitions. So this one will be, it's kind of columnar storage. If you observe what it mean by that, see this, so we cannot define anything here, we cannot create partitions. Only the thing is we need to understand the how the things is working in the backend. This is your the data when you So fetch any data from the table. Let's assume this is a sample data. Like we have type, name, country, and then date, right? These are the different columns we have, and then these are the rows we have. Now, when it is coming to physical structure, how it is going to store in the back end, observe this. So physical structure, it's created four partitions. This one is created four partitions. If you observe each partition, partition 1, partition 2, 3, and 4. Each and every column equally it will be divided into all the partitions. See this type column, it is storing in the form of row. This particular type column, see this one, each and every 666 rows, it is storing in each and every partition. See this 2 4 3 and then 2 3 2. So till, so here the first 6 rows it's stored in partition 1. Next 6 rows it is storing in partition 2. Next 6 it is storing in partition 3. Next partition 4. And when it is coming to the name column, again, see this one, first 6 in partition 1, next in partition 2, next in partition 3, next in partition 4, right? And when it is coming to again country column, each and every column, what is happening? Each and everything it is storing into different partition. Now, generally, when you are running a query, what will happen? It is going to scan the complete table, right? It will scan the complete table and then it will display the result, right? If you didn't given any indexes, hints, whatever it may be, it is going to scan and then it will display the result. But in case of this partition, what it will do is, for example, let's assume this is our data what we required. From this particular table, we required type 4, name C, country SP, and then date 11/2. This is what we required from this particular table. When we want this from this particular table, so where this particular data is available, it will check. In micro partition 1, see this one, we have 4, and then C, and then SP, country SP, and then so 11/2. So we have this data in partition 1. Instead of scanning all the partition, it is going to, Snowflake will understand, it will find out the data which we are looking for, it is available in partition 1, then it will scan only this partition. That's how it so identified in 10,000 plus partition, only 5 to 6 partition it has scanned. How come this one will understand? How come the Snowflake will understand whatever the requesting data, it is available here. That is available in this particular partition. What will happen is each partition, when Snowflake is creating in the backend, it is going to create the partitions range of values. Each and every partition, it will have range of values will be maintained. So that we will call it as a partitions metadata. If you observe, let me show you. This is how the data is storing in a row format, how the data will store in the columnar storage. So how the data looks like. And when it is coming to metadata, see this one. This is how the data will be stored. Metadata will be stored in the each and every partition. This metadata always it will be available in a cloud services layer. That's why without running any query, if you just move the mouse here on the table, so over the table, so just it will so show us how many number of rows we have. What is the size? This is from the metadata information, right? Same way here, if you
Yes,
observe
sir. I have
this
a
part,
question.
yes,
How can we means partition micro partition?
mm,
Means here you are sharing the screen and here is a micro partition one and micro partition two. How
correct.
can we partition that?
We cannot do anything. So it is automatically it will be created in the backend. We don't have any control on that. That's what I am telling. So when
Okay.
we are loading the data, when we are inserting the data into the table, automatically it is going to create a partitions in the range of values by default. Okay. So now if you observe, so let's say
While
it,
while Snowflake creating these micro partitions, what it
mm,
follow, what kind of rules it will follow?
we'll come to that. Okay.
Okay. The range of values, when you are saying, what is that meaning? Range of values for which column?
Coming to that. So
Okay.
let's give some time. So okay, we will
Okay.
discuss complete thing. Okay. So observe this one here. So if you see this, so metadata partition one. So what are the columns we are having here? Like ID and then channel and then city and then value and then month. So if you observe the ID, what is the range of values here? So what is minimum and then what is maximum? Observe this. Minimum is 1 and then maximum is 12. See this one. So for this particular ID, so we have minimum value 1 and then maximum value 12, right? In the partition 2, for the same ID, what is the minimum and then what is the maximum? So minimum is 2 and then maximum is 10, right? This we will call it as a range of values. For example, if you observe the value, so 150 and then 900 in there in the partition 1. The same thing if you observe the partition 2, again we have, so minimum is 150 and then maximum is 600. So like this, it is going to create the metadata. So for each partition, there will be a metadata will be available. So based on that, it will understand, so what all the partitions our requested data is available. So requested data is available. Sometimes overlap will be available. Overlap is possible. That overlap also we will see that. So this is how it is going to store the data. When it is coming to each partition data storing in metadata, at the same time, so what it will decide is when each partition, when it is going to see this one, micro partitions, it will have like this is a partition one, this is a partition two. So for this particular data, so this one, so 1, 2, 3, and then J2S in the order it has. So pick the data in the order partition and range of values in micro partition metadata. What will have is range of values will be there, number of distinct values, minimum and maximum, and then null count. These will be available in each partition metadata. Each partition, when it is created, the underlying micro partition, it contains these details. And when it is coming to each micro partition, see this one, this is one of the certification question. So each micro partition, it should not go beyond 16 MB after compression. After compression, what it will do is it won't go beyond so more than 16 MB. And at the same time, it is uncompressed data means it is 50 to 500 MB of the data. 50 to 500 MB of the data. What it will do is, so see this, automatically it will create, right? So continuous. So it is so units of storage and partition based on ingestion order. So how the data is ingesting into the table based on the order. So it is going to create the partitions and each partition. So it will be so up to 16 MB after compression. Without compression, the max it will be 500 MB. And see this one, when it is coming to, so it preserves natural data, so co-location. So it's so automatically it is going to so take it. And partitions are immutable. See this one, when update creates any new partition versions, partitions are immutable. We will see that. So in when we are working with streams, right, we saw that for every update, we will have two entries. One is delete, another one is insert, right? So how that will happen, we will see it here. Immutable. Every partition is immutable. It means, so when it is coming to, so it preserves natural data, so co-location. So it's so automatically it is going to take it. And partitions are immutable. See this one, when update creates any new partition versions, partitions are immutable. We will see that. So in when we are working with streams, right, we saw that for every update, we will have two entries. One is delete, another one is insert, right? So how that will happen, we will see it here. Immutable. Every partition is immutable. It means once the partition is created, going forward, if you have any changes, so we cannot disturb these partitions. So the new partition will be created. That is so immutable. The existing partition cannot be changed. So that we will call it as immutable. And see this one, this is built-in optimization based on, so automatically the Snowflake, it's complete SAS, software as a service, right? So we are not going to worry about any performance issue. It is going to, Snowflake provides, see this one, so patented micro partition pruning to optimize query performance. So to query performance automatically, it is going to like take care of that. And when it is coming this particular thing, we will call it as a pruning technique. If you observe here in this particular query id, you can able to see this one, pruning, right? The partitions, in total number of partitions, how many number of partitions it is scanning, that we will call it as a pruning technique. We used to call it as pruning technique. Now, so let's come to this. So it's, so so when it is coming to the, so this is optimization technique. So automatically it is going to take care of that, right? So we are not, no need to worry about any performance when it is joining the columns, when it is, when we are fetching the any data from the table. So automatically it will take care. So that is what, so it is telling. And so this one, so partitions generally, we will have different kind of partitions, the range based or hash based, but so we no need to worry about all these things. So but here when the Snowflake it is coming to, see this one, so key not used for any distribution. So and overlap ranges are okay. It means overlapping means here, if you observe partition 1, partition 2, and then partition 3. So in partition 1, we have the data from 0 to 26. In partition 2, 20 to 60. And in partition 3, 50 to 75. When you observe here, 0 to 26, right? 20 to 6, it is available here. The same values, 20 to 6, it is also available here. And same way, so here we have up to 50 to 60. Same 50 to 60, it is available here also, right? That is overlap ranges are okay. Initially when it is creating partitions, what it going to do is, it is going to create a partitions, so we put on some overlap, and then so it is going to create, so until overlap depth is 1. Overlap depth is 1. We will discuss that what it mean by that overlap depth and all. This is, so what, so the thing, so we are seeing here the pruning technique, and then so how many bytes it has scanned. So this is the thing. So now when it is coming to this particular thing, let's come to this. If you observe this particular thing, when the data is storing here, right? Let's observe this one, this particular data, the same table, so which we have discussed, the same table, when the data is inserting, right? Observe this one. So initially when the data is inserting, so here we have P1, right? Partition 1 and partition 2. This particular 6 rows, it's divided into 2 partitions. It divided into 2 partitions. When it's divided into 2 partitions, what will happen is, so suppose we have some new record, Steve, new record, Steve. We are going to insert new record, Steve. What it will do is, even though if the partition 1, after creation of the partitions, if the partition 1 is having a space, sorry, if partition 2 is having a space, it will not load that particular, insert that particular record into this any of the partitions. What it will do is it will create new partition. It will create new partition. Observe this P3 for the record Steve. So it's created new partition P3. And let's say in any of the partition, one record is deleted. What it is going to do is, for example, the record Andrews. So this one ID3 and then name Andrews. We are trying to delete the partition. When we are trying to delete the partition, what will happen is this particular record, it will be completely deleted, right? But the partition P1, it will be maintained in a backend as a version, and see this one, in place of that P4 will come. So that particular value Andrews has been deleted, and then that P4 will come into the picture, right? And suppose in this particular P2 partition or any of the partition, we have some updates or we have some updates. For example, anything. So this particular thing, Joseph, we wanted to update with some other specific ID. Even though if it is like we are updating also, what will happen? The partition will be deleted, previous one will be deleted. In place of that, new partition will come into the picture. The complete, it's a file, right? Complete each and every partition, if you consider it as a file, that complete file will be removed, and then new file will come into the picture. That's why if you observe in the streams also, when you observe for every update, you will have two entries,
Hello.
right? One insert, one update. Yes.
Sir, my question is,
Mm, mm,
what will be means happen
mm.
partition? Partition will be removed or it is keep as it
No,
is?
partition will be maintained in the backend. The
Okay.
version will be maintained. So for example, so when we are fetching the data, so first it will come here. So that's how it is going to work. For example, in our time travel, we can able to get the data for some period, right? So like 60 days or 30 days, we can able to get the data. Even though if the table, the data is not available, we can see that. So what exactly the data is available 10 days before data, right? So that's how this partition will be maintained in the backend. If you delete something or if you update, that version will be maintained. See this one, this is P4 now, right? What is the version before that? That is a P1. P1 will be maintained in the versioning, and then P4 will come into the picture for us, right? So when you use time travel option, so when you wanted to retrieve the data from the backend, then only you can able to, based on the timestamp, so you can able to understand, and then it is going to fetch the previous values, and then it will give it to us. Okay, so that is the concept. So how many days we have given, right? That retention period. So those many days, so it is going to maintain in the backend. Okay, we
So
are right.
for versioning, how many means maximum time will be keeping the record?
By default, what it will do is 7 days retention period. That is a fail-safe option. Fail-safe is nothing but any disaster derivative, we can able to get it back. So for any specific like 7 days, if you don't like maintain any retention also, right? For that, we need to send a request to the support team. So by default, it is going to maintain for 7 days. That is the concept. Okay, so now we'll come to that. So when it is coming to, so this is how it is going to create a partition. Okay, this is fine. But if you wanted to like do some like a performance improvement, or so if I wanted to understand what exactly the thing is happening in the backend, how come? So we can understand this, all these partitions it is working, like how come this partition will be created in the backend. Wanted to see that.
Sorry to interrupt. Sorry
Yes,
to
yes.
interrupt. Your voice is low. Can you be a bit louder?
Is it for everyone? Hello?
No,
We are
No,
I
able
can
to.
hear you.
good.
Yeah, fine.
Yeah, very good.
Yeah, thank you. Okay, so fine, guys. So if you observe one thing, so here any table, let's come to this. If you observe our Snowflake tables, right? See this one. Some of the tables you can able to see clustering key implementation. Let's say this particular table. See this one, cluster by option, right? This is cluster by option is available. So what is this cluster by option? See this one. So in here also we have used L ship date, L ship date, because so if you observe here, this is line item. So sorry, not here, this particular one. See this one, ship date, right? So this is L ship date. So because of this L ship date, cluster by option only, we have given this particular thing in a where condition. That's why I have given this is in a where condition. What this cluster by will do? It's a very simple. So we can, if you we can understand this like a order by column. For example, if you give order by, what will happen? It is going to sort out the data in a so ascending so or descending order based on our thing, like so based on our like order by condition. So it will give the data. The same way here also, if you observe, when you are giving cluster by, right, it is going to rearrange the data in a order. It will arrange the data, it will sort the data, and then it is going to give that particular data in a order. So it is going to store in this form. And when you are going to create clustering, right, we used to call it as a cluster by option. So when you are creating, we won't do this for every table. Every table it is not mandatory. Every table it is not mandatory. Some of the tables, if you observe, just a minute. Sorry guys, some of the tables, if you observe, see this, some tables only we have a cluster by option, other tables we don't have cluster by option, right? It is not mandatory to create a cluster by on each and every table. Only the table, if it is like greater than 4 to like so 5 terabytes, then only we can able to create cluster by option on that particular table. Otherwise it is not required. So when the data is inserting or loading into the table, so clustering metadata is collected and recorded for each micro partition. If you don't define cluster by, what will happen is, we saw this here, metadata, right? When it is storing metadata here, see sorry, here it is, see this one. So it is going to based on some of the key columns it is going to pick, and then it will maintain the metadata, this range of values, metadata values, it will be maintained so by default. So based on the key columns it is going to maintain, so mostly it will be a numeric. If you define any specific cluster by column, right, what will happen is it will give the importance to that particular column when it is maintaining the micro partitions metadata. Then what will happen? Whatever the column you defined, so for that particular column will be available in this particular metadata information. If you won't define, by default it is going to pick. If you define specifically, that particular column will come into the picture in the metadata. That's it. That is the only one thing. If you still wanted to increase any performance in your Snowflake, so remaining everything will be taken care by so Snowflake itself. So we are not going to do anything. When you define that clustering, right? So clustering, so what will happen? See this one, the clustering, Snowflake avoids unnecessary scanning of micro partition. It is not going to scan unnecessarily, it will not scan during querying, and it will accelerate performance of the queries. The same what it happened here. That's why we mentioned specifically L ship date. Then it is not going to scan unnecessarily. Only if you observe, in 10,000 plus partitions, it has scanned only 6 partitions. It identify where what is the exact partition it is available, right?
If
And
clustering
mm,
is not happened on this column, what would have
mm,
happened when you do
uh,
this where class?
mm, if you don't give the where case condition,
No,
it
no,
is
no.
going to take very lot of time. Mm,
My point is
mm.
clustering is not done on that column, but
Clustering is not done.
you have used
Mm,
that column in the where
mm,
class.
mm,
Is
mm.
it going to be a full scan, full table scan?
No, no, it is not going to like take it as a full table scan. And again, it is going to like search for the partitions where in which partition data is available. Instead of 6, maybe it will go 100 or 200.
Oh, okay.
Okay. Yeah. So because so if you define that, so specifically based on that column, it is there in a metadata. Otherwise, so it will again it will like scan more number of partitions and then it is going to display the data. Okay, so now so let's come to what will happen. So when so useful for very large tables, and so what it is doing in the backend, it is telling like automatically the maintenance performance automatically by Snowflake once it is defined, right? So no need to worry about that. Automatically it is going to take care whenever the data inserting. So and then when it is like fetching the data, so it will take care based on the partitions. No need to like any additional administrations. It is not required once it is defined. And when to most importantly, when to define clustering key. We will not define this cluster by on every table. It is not required. Only the huge volume of the table, at least greater than 4 terabyte or 5 terabyte data. And so queries on the table are running very slower than expected. So if your ongoing process, if you see that, so from up to last month, the queries are running very fast on that particular table. So now it is very slow. It may be a number of reasons. The volume has been increased or so have more load or have notified degraded performance over the time, right? Nothing but it is reducing, so it is taking very long time, right? So another thing is, so clustering depth is large enough for the table, nothing but so if it is coming to this, so clustering depth, we will come to that. It is nothing but the partitions are, it is taking very long time, so that also we'll call it as a clustering depth is so very large. So it means indirectly it is telling that we will see that how, so we can see so how, why we are calling that as a clustering depth. Okay, so clustering when it is coming to, it is expensive. So only the cluster when you so understand that query will be benefited. If you create a clustering by option on a table, then only we will do that. Otherwise, when you create a cluster, what will Snowflake will do is, so once define a clustering, it is going to be charged for the clustering. So when, if you observe this is nothing but a clustering depth. So let's just observe this. So what is, this is your data A to Z. A to Z data is available. So this is first level one. Okay. So so we will do this to easily understand. So bottom to top. So we have the data from A to Z here. See this A to D, it's divided in one partition, E to J in one partition, K to N in one partition. So D to S in one partition. This is another partition. When you are going up, so what is happening here? See this one. In the same position, same place, we have three partitions it occupied. And if you observe overlap one on one, this is two. See this one, overlap depth is 2. Here overlap depth is 1, right? Overlap depth is 2. But how many overlapping micro partition? 3. In the same place we have 3. From here to here, if you observe, so we have 3. 3 is a overlapping partitions. Here also if you observe 3, right? 3 is a overlapping partition. Overlap depth is 3 because, so if you observe the black line, so overlap depth is 3, the same place it is occupying. Here if you observe the 5, overlap depth is 5, and then overlapping partitions also, so 5, right? This is your first level. This is your level 1. When the data inserted into the table, it will insert. Then each and every level, when it is doing, so when it will check for the overlap this particular depth, and then it is going to so keep the data until this level, until it comes to this level, it will keep on the partition, and then it will distribute the data to this kind of the partition, and then this kind of overlapping. So overlapping should not be available till this particular range. So it will divide the data. It is going to divide that particular partitions. So this particular thing, so some clustering in the back end, so clustering mechanism algorithm will run in the back end, in the back end. So that particular algorithm, we will see that. One second, guys, just give me 1 second. Sorry. Now if you observe what will happen in the back end, see this one, this is the thing what it is going to do in the back end. So without any our involvement, whenever we inserted the data, it is it will, so what it will do is it will wake up. So when the data arrives, that nothing but, so it is going to create, see this one, clustering partition selection algorithm. Clustering partition selection algorithm, this is the algorithm it will run in a backend. So the data arrives, this algorithm will wake up. It will split the table files into levels. That is nothing but we'll call it as a clustering state. Clustering by column is different. Clustering state is different. Clustering state is nothing but, get confused here when you observe this one, right? Each and every level when it is coming, this is a clustering state. So I'll cluster by column is nothing but which column we are going to decide to maintain a range of values for micro partition, right? So it is, so table, so it will split the tables into levels, nothing but a files. And so that is clustering state. And once it is divided into this like a files, it will check for overlap values. It will run partition selection algorithm on each level, and it will queue up, recluster the task for execution. What it will do is in the back end, so it is going to understand, it is going to like create each and every level when it is coming to, it will distribute these particular levels in until this level it comes, keep on running this particular algorithm. And if it finds the size is right and there is no non-blocking means there is a overlap, until this level this algorithm will keep on run. After that it will stop. If the clustering depth is not good enough, then what it will do, it will repeat the same algorithm. Otherwise, it will sleep. So when it will do, whenever the data is inserting into the table, whenever the data is coming into the data is loading into the table, so every time the clustering algorithm will wake up, and then it is going to execute this particular task. So what it will do, it will distribute the data, the files, and then until this level it is going to maintain that in the backend with the range of values. Okay, that is what it is going to do in the backend. This is only one thing what they have so relieve it to us how they are giving the, how they are building the partitions. There is completely their architecture, that's why they have taken so on this, so a patent rights also on this particular the mechanism. And so if you observe, So when you created a cluster by, what it will happen? So generally, so if you wanted to create a cluster by, so how to create a cluster by, we will see that how we can able to do that. So this is again, so how the clustering depth algorithm will work. So how the things is going to be, like the range of values will be available. The same thing. So here, so clustering key. When you create a clustering key, and one more thing, we should not go as per the recommendation by the Snowflake. We should not go more than so 3 clustering keys on a table. We should not go for that. And so this particular clustering key, right? When you define, we can define and then we can so undefine also. So once you don't want, you can remove that particular clustering by on a table also. We will see that practically how we can able to create a clustering key on a specific table. So what it will happen on the clustering data. So when you are created a clustering key, right? So what will happen is Snowflake will charge for that. If you observe here, see this one, Snowflake keeps the clustering order update in the background, the build on per second basis. So how much time the cluster, so it has been utilized. So based on that, so it is going to bill per second basis. This is also one of the when the serverless future. So when this clustering will work, whenever the data arrives into the table, at that time only it will wake up and then it will distribute that particular run, it will run the algorithm, it will arrange the data in a order, right? So it will so be chargeable. And this is again the how the clustering level will work, so that algorithm will work. So this is a level 0, it will divide the data into these levels, so nothing but a files, and then so rearrange that so until this particular level. So this one mode partition with order range of the data. So this is the best thing. So best possible way, so how it has defined in the backend. So until this level, it will keep on implementing. Once this level is reached, there is no overlap. So then, so it will decide that. So if so the same data, if it is available in, for example, if you come to this, it is nothing but a full table scan, right? If you come to the overlap, the same data, if it is available to two places, I mean two files, then it has to scan both the files. If the same data is available here, if you observe this is 3, right? 3, so it has to scan all the 3 partitions. Instead of that, if it is available like this, then it is not going to worry about, so the individual partitions will be there, then unnecessary scanning will be avoided. So by using this, so particular clustering so level algorithm, this is again the same table which you have discussed. And so let's observe, so how we can able to create a clustering key for this particular implementation. So it's very simple. When you created a table, by default we can able to create a clustering key. Like if you observe this, but so remember, every table we won't do that, we won't do that. For this generally, so we required a permission from the, so your senior team or the business, so the persons, because it is going to be chargeable. For example, when you're creating a table, what we are going to do, we will create a table name, and based on column name data type, column name data type, till here we will do that, right? We will create a table, column names and data types. When it is coming to cluster by option, see this one, along with that, we are going to define cluster by on which column we want. So here, if you want on the 2 columns, we can give cluster by C1 and C2, C1 and C2. So if you observe this, the cluster will be created on this particular table. Let's observe this here. If you see the table T1 which you have created, see this one, so you can able to see the cluster by, it's available cluster by on C1 and C2, right? Same way we can able to implement partial clustering also. Partial clustering, it means, for example, so first 5 digits, so is account number. The next we have a last name, and first 5 digits only we wanted to sort out the data. Wanted to sort the data, we wanted to keep it. Then partial clustering is possible. So for that, what we can do is, so we can give, see this one, we can give like this, clustering by, see this one. So for example, so I need, so only this particular, only on C2 column, only on C2 column from 0 to 10. C2, so string will give, so 0 to 10 first account number, 0 to 10 is account number. After that we have a last name. Then we don't want on the last name, we want on a account number only. So partition is created. This is range of values, so we can, so I mean, so we can create a partition based on this. So partial partitioning, we used to call it as a partial partitioning. So if you observe T2, see this one, for that string, so first it will consider 0 to 10, right? So and same way, already suppose we have created a table, already we created a table. On top of that particular table, we wanted to create a cluster. We can do alter also. So if you observe here, so we can alter cluster, alter cluster. Same thing whatever we have discussed. So all it is available here. Alter table. If you wanted to drop a clustering, we can drop the clustering based on the key. And then if you wanted to alter column, so we can able to alter table column name, and then cluster by, we can add it. We can add it. So alter table like a cluster by, and then C1 and C2. So if it is not available, if it is not available on existing table, we can go with the column name also. This is another way. So how we can alter existing table if you wanted to create it. If you wanted, if you don't want to like create, if you want, if you don't want like the cluster by option, it is available. What we can do is we can drop clustering key on that particular table, table name, drop clustering key. That's automatically it is going to drop the cluster by option on that particular table. All right. So these are the options what we can able to perform. So only the thing is, so we have to create a clustering key on any table. That is only the one way how we can able to increase the, that is also not supported automatically. That's why we used to call, so Snowflake, so no need to worry about performance. Automatically it is going to take care of the partitions. Always it will make sure that to give the best performance. So when we are like accessing the so data, it is going to take care from the back end. Okay, so now, so this is the thing. So you can go through the document. Some examples also I have given here, the clustering and then partition, both the things. So we don't have anything like the see the things the practically more than this, because it is not accessible for us. There we don't have any control on that. Okay, so next session we will jump to the AWS implementation and all. We will see that how to do that. Don't worry about if you don't have any knowledge on the cloud, whatever it is required for us, right? So for the Snowflake, we will discuss those things. Okay, I will explain those things also. Now let's come to the questions here. Rakesh, is it resolved, Rakesh? Maybe I think it's from your side. Can you clustering key defined with multiple fields? Yeah, yeah. Multiple files within, yes, more, not more than 3. Yeah, fine, fine. How the partitions creation happens? Suppose we are loading data using match up 10 GB on each run. So how Snowflake creates partition? Yeah. So whatever it may be, Kiran. So whenever the data loads, right? Whenever the data is loading into that, immediately it will start creating a partitions.
So how many records for each
It
partition?
does. It doesn't matter. It will not about the like how many records and all. Always
Oh,
it will take based on the like a compression size.
okay. So compression also while loading itself, it will happen.
While loading itself, it is going to take care.
Okay, if it reaches the to the size of the compression,
Size,
and then
yes,
it will start creating the next one. It will go for it.
it will go for the next one. Yes, correct.
Oh, okay.
Yeah. Someone is asking question.
Yeah, my question is resolved, Dinesh. Thanks.
Yeah. Okay, Shruti.
So hi. And so sometime what happens, like we have a like huge number of fields in a table, right?
Mm,
So
mm.
and I think there is a limitation that this partition files cannot be more than what 10 MB or whatever.
16 MB each file.
16 MB each file, fine.
Each
So
file.
for in fact in my warehouse at one point of time I had close to 60-70 fields just on one table, and there were more like that. So something like that, and of course some of the fields will be very large. So that means some of your records may be spanning across multiple partitions. So is it something like some
No.
criteria that when you have too many fields, are we supposed to do something special to make sure that the performance is not the issue, or you just don't have to worry about anything and everything has to be done at the background? So
Understand your question, Vipin. But we are talking about the file size. File size is 16 MB. But here the field size you are talking about, it is nothing but a column, right? So after compression, so generally, so it may have like the every field will have some data, right? So, but when it is coming to here, it is going to compress the data after compression of the file. So what it will do is the regular data, it will compress, it will keep it in a file format, and then it will compress. It will be generally, if you observe, it will be gzip by default. So it will be a file format. So file we are talking about, that is nothing but a file size, not the field size.
right. So yeah, I got it. So actually, I was meant to say the file size only. That if I have too many fields, right? Then there may be a situation where one particular record is not able to fit in one file.
In one file. Got it. Yeah, then it will go to the next partition. If you observe here, the same thing. See this one. So whatever the fields it is available, see this one, ID and the name. So it's available in a partition one, right? So it's like so your like a thing is you are telling, for example, we have ID, name, and then city, value, like that. So we have 100 fields is available. All the 100 fields, it is not accommodating in one particular partition, right? So what will happen? So next thing, so will happen to next thing, remaining thing, it will be taken to the another partition.
Right. So the reason I'm asking this is, so if we have a situation like that, when I know that one of my record may not be able to fit in into the partition, and just to, so
Correct.
is there something we should consider that these many fields should not have, or
No, it's not like that. We don't have any control on that, so we cannot do anything on that itself. So we cannot restrict the data, right? We cannot restrict the table and then columns. Okay, so no matter the how many fields is available and then how much data is available, so it is going to take care of in backend.
Okay.
Hey,
Any other questions? Yeah, Mohan, tell me.
Dinesh. So basically, I had a question. I think my question got resolved with the clustering state. So I thought,
Okay.
like for the optimized reading from the table, because we had, I mean, if a table has more updates or more inserts with the similar range of data in a particular column, where the
Mhm.
clustering, automated or manual clustering,
Mhm.
clustering key maybe. So in that
Mhm.
case, I thought like we at some points if we reload a table or if we can create a new table with the sorted data, sorted in a particular
Mhm.
like ID columns or something.
Mhm.
So that would be our optimal reading, but Snowflake itself, it rearranges the data after some time, right? When
Correct.
we have more like depth,
Data
I mean
volume.
overlapping depth,
Overlapping. Yes.
overlapping depth. Yeah.
Mhm.
So this overlapping depth, if it requires to rearrange,
Mhm.
the Snowflake has to sort the data on particular column.
Correct.
Then rearrange. It should rearrange, right? So that too,
Exactly.
it's not like a single. It's not a single
Single
step.
field. Yes.
It can create. It can
Mm.
come to the bottom level. So it has to
Correct.
multiple times. It has to sort the data and arranges between these depths. So
Mm.
it if we have a table with terabytes of data, it will take a
Mm.
lot of time, right, to sort the data and everything. So in that
Mhm.
case,
Mm.
if you have a like lot of, I mean, there is a concept we use with the Snowpipe to automated data loading.
Mm.
So in
Mm.
that case, if we keep on loading that data into that table, how, I mean, when it is take time to rearrange the data, if the incoming data is huge,
Mm.
lot
Mm.
of
Mm.
updates, lot of inserts happening, when
Mm.
it is going to rearrange the data every time, like
Yeah, it
it's
will.
not a
Yeah.
it's not a
Understand.
one time
Yes,
activity,
yes,
right?
understand the question. It is not one-time activity. What will happen is most of the time, so this kind of clustering case, we are going to implement mostly. So when we are fetching the data from the table, so for any reporting purposes, right?
Mhm.
Generally. So what will happen is so our case, as you discussed, the Snowpipe, whatever it may be, like continuous ingestion process,
Mhm.
already the data. So we are not going to do it at single time, right?
Yeah,
So we
correct.
cannot like load so more than 1 GB data at a same time. So
Mhm.
it will be like less than 1 GB is preferable. So
Okay,
generally, as per the Snowflake standards, the file size it should be so less than 600 MB.
that is
Okay.
incremental loads,
So
right?
that is incremental loads. When it is
Okay,
coming to incremental, the reason behind that is backend, as you said. So 600 MB one time when you are loading, so it have a lot of time to like rearrange the data. It will do that in the backend if it anything it is required.
correct.
So and so it will
Sorting
not
is
take
a
much time also.
expensive
Yes,
transaction.
expensive. Yes. So that's why. So each and every time. So for example, today some data came morning and then evening, and in between also there is a time to like rearrange the data. It will do it immediately.
Okay, and that too, it requires warehouse to be active, right?
Yes, warehouse to be active. Yes.
Okay. Yeah, that's why they're charging us to for rearranging this
Correct.
clustering everything. Yeah, otherwise
Yes.
it'll be a
Mm.
burden on them. Yeah,
Yeah.
and then yeah, that is one question. Yeah, and each file you said like maximum 16 MB. I think Vipin had a valid question. Uh,
Mm, mm,
with a
mm.
if we have a one row, if it is
Correct.
after a compression, though
Mm,
it, I mean that particular row, what
mm,
if it has more than 16 MB after compression? That
mm,
is the
mm,
question. I
mm,
think
mm.
he had a valid point.
Correct.
And
Correct.
that,
Correct.
and why are
Mm,
we discussed about this uncompressed data, like 50 to 500 MB? You said like that's
mm,
a limit.
mm, mm, mm. Yeah.
So
Yeah. Mm.
yeah, but there is no concept in saving uncompressed data in the Snowflake.
There is no concept. Just
Correct.
so if
So
you
by
wanted to
default, it
calculate it
compresses, and that
by
too
default.
we don't have control on that, like the
Correct.
compression
Mm,
technique. It is
mm.
default to gzip. Then why are we
Yes.
talking about this uncompressed data? So
Just to understand like how much it will be. So if you compress, it will be 16 MB. If you don't compress, what will be the data size? That's why they just mentioned it. That's it. There
okay,
is no
okay,
concept, any other specific reason behind that
okay. For
implementation.
gzip,
Just
I
to
think
understand.
maximum like 40% or it compressed to like
Yes,
100% of data. It compressed to, I think, maximum
up to
max
40 to 50, I think.
40 to 50. Yeah. Then I think it's 16 and 500 is MB. Not, I mean, not
Mhm.
the figures are not close.
Correct, correct. That's why they mentioned in between 50 to 500 MB. They're like,
Yeah.
okay, yeah.
Yeah, if 500 MB maximum we decompress it, it will be like 30 to 50 MB around, right?
Mhm.
And then yeah, yes. Yeah, and I mean, is it like we
Mm.
have to save the versions and partitions are not mutable, right? Not, I mean,
Mm.
are immutable.
Immutable.
So even if it rearranges the data
Mm.
into multiple layer, I
Mhm.
mean, multiple depths.
Mm.
So whether Snowflake is like keeping all these rearranged data,
When it is coming
will
to
it will it
rearrange
will
the
it keep
data,
all the could you please go back to that
nothing,
slide
nothing.
where we
So versioning you are talking about, right?
yeah yes it's a follow-up question with that as well. I need this clustering
Yeah,
state
to
basically.
come to that.
Yeah, here if you have like first level 0, we have if it has maybe 2 or 3
What?
partitions,
Correct.
we
Okay.
have
And so this
like
is
1
the
2 3 4.
final thing it is going to maintain.
Yeah, will it keep all these files like 0
No,
level
no, no.
1 level 2
It
level 3?
won't keep all these things. It will keep the level this one. It will like finally it will be available here. Again, if you have any changes later on, this version will be available.
Okay,
On top of that, a new version will come into the picture.
and the new version will be rearranged but not the old version, is it?
Yes, exactly.
Okay, okay. So there is a lot of engineering happening in between, I guess.
Correct.
For the versioning,
Mm.
do they have any specific I mean, Snowflake owned versioning, or they'll utilize only the cloud storage versionings to keep
They
all
will
these things?
utilize, no, no, we don't have any specific things. They are going to utilize the cloud things only,
Okay,
what they are
so
going to provide.
okay. So maybe I mean internally it will keep the version ID for a particular
Mm, mm,
file
mm.
in the metadata.
Yes.
Okay. Yeah, I think yeah, that's all my questions.
Just go through
So,
that one more time. It is like a topic called like we need to understand based on the theoretical concept, right? It will, so I understand it will be difficult to digest it. So, but so we don't have any other option. Just go through that one more time. If you
Yeah,
have
I've gone
still
through
any question,
some of the
okay, so
documentations.
we'll see that also.
Yeah,
Yeah.
and one more thing, I think last Friday, Thursday, I
Mm,
asked a question on that,
mm,
right? Like
mm,
preview requires the warehouse or something. So I found that
mm.
answer. It
Okay.
preview also it requires a warehouse. If you
It
open a
requires a warehouse.
documentation,
Okay.
d-
If I click on preview, it is like fetching the data.
correct, fetching the data.
So for example, if you preview the first 100 records, it will fetch from the any table,
Yeah.
right? So if it is from the metadata, it won't require anything, right? So if it is fetching the data from like the 100 records, first 100 records, then so it started.
Started. Yeah, I see the documentation as
Yes.
well. They said like it requires the warehouse.
Mm,
If nothing selected, it takes the for that
or
particular
default one.
user, it uses the
Mm,
default warehouse.
default one. Yes. Yes.
It's in a
Good.
table details
Yep.
documentation.
Yep.
Yeah.
Yep. Good. Man.
Thanks.
Thank you, man. Yeah. Any other questions?
Yeah, so with this
Everything.
extensive the process, what happens behind the scene when we load the data, especially with respect to the clustering. So is there how frequent we can update our data in data warehouse? So is that something we should limit that,
No,
the data
we don't
warehouse, you should refresh
Mm.
1 hour or 6 hours or something like
No.
that?
No, we don't have any concept like that. So it's up to us. So it's up to the business requirement. We can able to do that. And one more thing, basically, generally the refresh, right? The reporting layer, if you want, we have some other concept called materialized view. That also automatic refresh will happen from the backend. There is a mechanism for that. That we will call it the background maintenance service. So that is the one mechanism they have introduced. So especially for the reporting layer implementation, we will discuss that.
Okay.
But here there
Dinesh,
is no limitation. Yes.
sorry to cut you.
Yes, Mohan, tell me.
Okay. So I think if we like for this optimization reading, so if we have a table that we continuously load, maybe daily loading, but an ID column or any take it as a primary column maybe. There is no primary concept column concept here, but it's just a primary
Okay.
column kind of thing. So if it is not like the same ID, or if you keep on creating the new IDs or in that table, so is it a if we get any benefits if you load sorted data every time before loading into the table, so that if we sort it, I think it won't like
It won't
take
take
more
much time. So I
more
understand your thing.
rearranges. Yeah.
Yes, yes. So before loading itself, we are sorting the data and then we are loading it, right?
So
Yeah.
so that definitely take an
That will not take
advantage, right?
much time. Yes. Yes.
Okay.
Dinesh, there are,
Yes.
on the overall, what can we say? Like Snowflake is a column storage or the row storage, or both are not, and it's actually a micro partition.
It's a columnar storage.
It's a
I
columnar
can say that it's
storage,
a columnar storage. Yeah.
but actually
And
it's not happening like that, right? The micro
yes,
partitioning.
yes. Yeah, it is a columnar storage. We can say that once it is stored in the form of columnar storage, and again this columnar storage, so we'll divide it into the partitions.
Yeah, but the partitions are into row based
Micro partitions.
right? So
Micro partitions.
yeah, that's one thing. And then the other thing is Snowflake having archiving capability.
Archiving capability, no. So what we can do is we can compress it. That's it. But it depends. Like archiving, I never checked it. I will cross check once. So
Okay.
what we will do is generally, so it is anyway cloud storage, right? Whatever the data we don't require, like more than 5 years back data and all those things. So we will keep it in generally. In my case, what they are doing is they are clipping in a storage buckets.
Okay.
The
S3
archive the
buckets.
data.
That's what they.
Yes, yes, S3 bucket. They
Okay.
are not equipping that into the Snowflake anyway. It is not required.
Okay.
But
So in the
within
S3.
the Snowflake itself means I have to check once.
Okay. When they keep the data in the S3 bucket, this clustering, if the user want to do any reporting on the S3 buckets, so
No,
this
they won't do.
clustering will not work, right?
Will not work. In that case, it will not work. Whatever the data we are frequently accessing. So let's say some business they required only 2 years data, some business 5 years data, 10 years data. So every business, it's not required more than 10 years or 20 years data, right? Whatever the data, it is not required. So for frequent analysis purpose, what they will do is they will archive that data.
Yeah.
Unnecessarily we are keeping that in a
Usually.
storage. Yes.
Yeah. So my question was actually even after archiving, for that archive table also, can we have this clustering applicable,
No,
you know?
no. Understand, got it. But so no, that is very difficult, not possible.
Yeah, for
Okay,
this archiving, it's not an Snowflake
It's not in
storage,
Snowflake.
right? Internal storage.
Yes,
Again,
that
we
will be
have to export that into files
additional.
and then keep it in our own cloud, right?
Correct.
okay, all right.
Okay, guys, good discussion. Okay, see you tomorrow.
Yeah.
Thank you all.
Thank you. Thank you.